all good? Okay. Hi everyone, welcome back to another episode of Munro Live. I'm Julian. I'm an associate engineer here at Munro Associates. For those of you who don't know, Munro Associates is an engineering consulting firm. We specialize in competitive benchmarking, costing vehicles, as well as teardowns. Today we'll be looking at one of those teardowns, which is the high voltage battery pack from a Porsche Taycan. So we're going to start with some of the exterior, go into the pack itself, look at some high-level construction details, talk about the configuration between the variants of the pack, and then also look a little bit at how they've constructed their module. So at a high level, the Taycan battery pack has a fair bit of unique features relative to the other battery packs that we've torn down here. For instance, what we're going to start by talking about is this integrated power distribution unit that actually what we're looking at here is the bottom of this. It's a two-piece cast aluminum enclosure, which contains all of the components that, like with a Tesla or a Lucid or most other battery packs, are integrated into the battery box itself. So we've got a set of contactors, our main positive and negative terminal coming from the bus bars on the modules inside the pack. And then we have some distribution inside here for our front and rear drive unit high voltage connections. So this in itself is a separate unit that is enclosed, built up offline, and it is then installed and bolted to the top of the pack. The primary interface between this and the battery modules themselves is through this sealed interface where we have a low voltage connection for communication with the battery management system inside this unit, as well as the two terminals, which again, these are gonna tap right into the main positive and negative terminals from the bus bars inside of the battery pack. At the front and rear of this unit, this being the front, this actually sits right at the leading edge of the front of the battery pack. So we have the pack here, and so if this were in vehicle, that end of the unit would sit right around here. That is actually the location of the only CPA or connector positive assurance cam lock high voltage connector to the battery pack that's featured on this vehicle. So that connects to the front drive unit, as well as the DC-DC converter and some of the other high voltage monuments. For the rear, you can see that there's actually no connector interface. It is strictly two terminals with fasteners, some tapped holes for fasteners. So what is interesting about the way that this battery pack is constructed is we have high voltage cables that are fastened on with threaded fasteners, and then that cable is run along the length of the battery pack to the rear, and then it would extend upward toward the right end of the vehicle here. And in order to remove the battery pack from the vehicle, with some packs we need to remove some carpet or some soft trim to gain access to fasteners on the cabin side. There were no such fasteners with this pack. However, in order to fully drop it, the cable that runs along the top of the battery pack and connects to the rear drive unit needs to be accessed through a port or a hole essentially in beneath the load floor of the trunk that's about yay big. You have just enough access to get an Allen key in there and undo the three fasteners that are needed to disengage that connector from the drive unit, and it's then able to snake through the rear suspension as the pack is dropped. So relative to some others like we see on a lot of Tesla packs or even Lucid, the Ionic, some other recent ones that we've done, removing this from the vehicle presented its own challenges simply because of the way that some of these are done. This is a lower volume vehicle, so that's somewhat reflected in the way that it's installed and some of the assembly or de-decking processes that need to be taken, such as in a higher volume application, we wouldn't see something that would require an operator to, climb in through the load floor, attach the cable that way. There would be a much quicker way to disconnect that right at the battery pack for ease of installation or serviceability for removing. With the high voltage distribution out of the way, what we have here is the battery box itself. So we have all the covers removed. And I believe I misspoke before, actually. What we're looking at here is actually toward the rear, and then up toward the front here is where we're going to actually be forward in vehicle. So we have the two exterior coolant ports, which is fairly typical. Something that the Taycan has done here is they've taken a more integrated approach with their thermal management for the battery. So if we take a look inside this sort of front corner area here, we can see we have one of the coolant's lines, either supply or return, and it necks down, and you can see that we have sort of a manifold that branches out into 2 micro-extruded aluminum channels that are then glued to the bottom sort of bulkhead for the battery enclosure here. And so they've got a distribution of what we're going to see is one end, say if this is our supply, we're going to flow the coolant in. It flows, it has a main hose or line that will carry the coolant down the length of the pack. It will send the coolant across, and it will be collected and flow out of the return. So we have a fairly straightforward integrated approach here. I know when we've taken a look previously, we had the Volkswagen ID4 had a pretty, they had an integrated cooling plate. However, it was much more complex in the way that tortuous path was designed with a 2-part stamped and brazed aluminum cold plate assembly. Similar with the Ioniq, we saw a more simplified path for that coolant to flow, but we were still looking at a 2-part stamped and brazed assembly that formed the bottom of the pack. Here we've got a combination of a more standard battery pack design with fairly inexpensive and relatively simple extrusions to carry that fluid in a pretty linear path just from one side of the pack to the other. And so we can also see around the top of this, before we're able to actually get into the pack, what we have along the edge is, here's a good place to take a look at it. There is a fairly thick bead of adhesive that's used to seal the pack right next to a series of thermal flow screws. In order to open this pack, we actually used a oscillating tool with bits that were specifically designed for EV battery pack teardowns from Fine Tools. So that made pretty quick work of this, and we were able to maintain the integrity of the lids as we removed them. The typical process for this is prying it up, which in itself can have some hazards because there's issues with controlling the depth, and obviously when you're unfamiliar with the layout of the battery pack, or even if you do, you want to prevent your tools, especially if they're metallic, which is often needed to breach the seals on these lids. You want to make sure that doesn't extend too far into the pack, so using the oscillating tool with sort of a set depth to enable some safer but also swifter openings of these lids, that was very, very helpful to use on this pack in particular. So thank you again to Fine Tools for lending that to us. So on the subject of the lid, we can see from the top down, we've got the blue that's visible, and that's all our thermal interface material from underneath the modules. But we can see in between sort of the front and rear halves of the pack, we have these 2 vacant areas right here. And if you remember from the Lucid, either from the Tech Talks they've published on YouTube or from our teardowns, there was in the differences of trim levels for the Lucid battery packs, whether it was the extended or standard range, they would decontent certain areas of the pack. And by decontenting and removing modules from roughly the same area toward the rear of the pack, Lucid was able to afford additional second row footwell space, or what they referred to as a foot garage. Porsche uses similar nomenclature to describe this area. However, one fundamental difference between how Lucid accomplishes this and how Porsche does this is standard on every variant of the pack. You can see that this bead that we're looking at for the lid goes all the way around and leaves this space open to the floor of the body in white. Will dip down inside here. And there are no mounting features, there are no cross members in here, so there is no version of this where modules live in this space. So this is carried by every version of the pack, and as a result of that, they need to make concessions by routing between, similar to how Lucid has in some of theirs, running between 2 separate chambers or sections of the pack that have a discontinuity between them. To that point, so just some high-level details that we've glossed over in terms of technical aspects of this. What we have in front of us here is the performance battery pack for the Taycan. This is the 79.2 kilowatt hour version with a nominal voltage of 520 volts. There are 28 modules inside of this with about 12 cells per module. So this pack in total will have 336 cells linked together in a 168 series 2 parallel configuration. The Performance Plus, which is their extended range, has a nominal voltage of 720 volts with 93.4 kilowatt hours. That is going to have additional modules both in a vacant space in this base, which we'll talk about a little bit later, but they also add some additional modules in sort of a penthouse or second layer on top. So that's got 33 modules, so 5 more than what we have here. 396 cells total for that battery pack in a 198 series and 2 parallel configuration. So we're looking at the smaller variant of the pack, and one thing that stood out to us relative to how we've seen packaging space leveraged in other applications is the fact that in this corner here, you can see that there's an absence of thermal interface material, and that's not from us scraping it off after removing one of the modules. There actually was no module in this space. So if we're looking at how this is laid out, this is all going to be enclosed under the lid anyhow. This module was intentionally, it's essentially wasted space if you want to talk about this pack from a volumetric and a gravimetric efficiency standpoint. If you're going to have 2 different variants of the pack that will have, give or take, a few modules, we haven't typically seen OEMs willing to just give up space like that. Typically, any bit of additional capacity or voltage they can squeeze into a given area, they will. However, this is an intentional decontenting of available space that's already present on this version of the pack. It wouldn't require any additional space or that penthouse like they would use for the 4 modules that don't live in this main primary base layer of modules. So that's one unique aspect of this pack design that we don't typically see, but again, this is a lower volume application and it is for more of a luxury performance EV. So there can be some liberties taken there, but again, for high volume applications, we're typically going to see EV manufacturers try and squeeze every bit of both volumetric and gravimetric efficiency they can. Again, going back to comparing with Lucid, because there are some architectural similarities here. That was an incredibly well packed, well nested, very densely fitted battery pack on the interior. And in the certain instances where they did omit modules, they even reshaped the lids to form around what was still present on the pack, and then leaving that space open for the second row foot garage. So that was just something that stuck out to us as slightly abnormal. But in terms of the modules themselves, we do have one that we've sort of opened up and we can take a look over here. And again, we have taken a look at an ID4 battery pack before, and this is going to look fairly similar for anybody who's familiar with that battery pack. And what we have here is an extruded aluminum housing with a square profile. With what we've removed since are 2 cast aluminum end caps that are welded to the ends. So we've removed those end caps, and we can see on the inside we have the 12 pouch type cells on the inside wired 2 in parallel. So we have 6 series here with 12 cells total. So that's how we get up to our 168 cells in series with the 2 in parallel. So that's how those are correlated. We have a small battery management system board right here that's attached to the cells for the cell taps via flex cable. And we haven't torn this down any further because with this type of module construction, you're going to want to make sure that you have the pouch cells situated very firmly inside of this enclosure. One advantage to this is because you have such a rigid structure to enclose your module. Well, extrusions, first off, relative to other pouch cell module housings, this is a 3-piece module enclosure. You have the primary enclosure and then the 2 end caps. We've seen others which have end caps, a 2-piece clamshell, which is a stamped aluminum, various other ways of accomplishing that that just have a much higher component count. And extrusions too, by weight, are relatively inexpensive, and the tooling is inexpensive as well, relative to, again, something like a stamping, which we'd see with something that's got a slightly higher volume. This being lower volume, it makes sense that we'd see an extrusion, likewise with the rest of the pack, used in the module construction here. So with the pouch cell situated on the inside, one of the differences, and I would say from my perspective, the disadvantages to a pouch type cell relative to a cylindrical or a prismatic, is that they are fairly delicate. They can't take as much physical abuse as a prismatic or a cylindrical because they simply don't have the innate structure on their own. That's why we typically see beefier modules when we have a pouch cell, because they can't provide that structure on their own in the way that a prismatic or a cylindrical can. And so they are secured very well inside here, and so as to prevent the pouch film from actually tearing, we've left them inside because that was one of the observations we had made with the ID4 previously, is that this type of module construction, which is very similar to how the ID4 accomplished theirs, it's innately a little bit difficult to remove the cells from something like this. So we've left it as is, but it's you know, good to be able to speak to it as a constructed component here. All in all, it's an interesting data point to have. There's some definitely bespoke stuff going on with this pack, from the decontenting of certain module areas for the different trim levels of the pack, along with the integrated and externally mounted power distribution unit system that we've got. So this was a very interesting teardown to do. Definitely a lot of good stuff to see here. And we have done other battery pack teardowns. You can actually see behind me both a Lucid Air and a Hyundai Ioniq 5. We've also done various Teslas. So if you have any interest in any of the data that we've collected, we do fully costed reports, we do teardown analyses. If any of that's of interest to you or your organization, please feel free to reach out to sales@leandesign.com, and we'd be happy to speak with you and get you set up with any of the reports that you'd be interested in. So thanks for watching, and tune in next time.